Homework. In order to get a little bit better the feeling of those things, I prepared a few questions. The first one, to get a little bit used, is forces. So you have a conical pendulum, as in the figure, and you want to find the angle of the vertical direction if you know the angular velocity. That will combine a few slides that we had. The other one to get you a feeling of what kind, size of units we are talking. Because that will be very important to get when we move to the modern physics, understand which units are small, what are large, what can we ignore, what we can expand in something. So we want to check that you know to understand the gravitational field. So a good exercise is to calculate the acceleration caused by the gravitational field of the Earth on the Earth's surface. We know the answer. We have to come up 9.8 meters per second squared. Interesting question is to find the velocity of our rocket to escape the Earth's gravitational field. And one problem for electromagnetism, electromagnetism. Assume an electron revolves around a proton, a circular orbit of radius 1/2 angstrom. That's typical radius on the first level in atom, the hydrogen atom. So to find what is the velocity of the electron and what is its frequency of motion. It is gives you the first approximation to understand what is difference between the things that we are used to and that we want to reach to understand. Okay, that was the homework solution. Number one, they said problem one was conical pendulum, as in the figure, an angle alpha has angular velocity omega, and we want to find what is the angle. So F equals ma. You have the force now looking on the vertical direction. Here you have, on this side you see, the tension T. The projection of the vertical direction is cos T cosine alpha minus mg. This is the vertical minus the horizontal one is equal this is the centrifugal force that we found the formula. Now we substitute all the values, and we got from this equation, from the equation T cosine alpha minus mg has to be 0, because it's not moving up and down. You get the value of T, mg of cosine alpha, and then from here you substitute and you get T sine alpha here equals mv squared over 2, and mv squared over 2 is m omega squared. A, what is A? So we got sine m omega squared over t, sine alpha, and we got tangents of cosine alpha equals arctangents and omega square A over G. So we have, and A is the length of the string, L. Okay, that's the solution of the problem one. Problem two was find the acceleration caused by the gravitational field of the Earth on the Earth's surface. We're using the formula that we got. A is equal gm over r squared. G is this value written down, mass is given, r is also known, and we got the well-known 9.8 meters per second squared. Problem number three, find the velocity needed for a rocket to escape the Earth's gravitational field. And the escape velocity is the velocity that the kinetic energy plus the potential energy is 0. Therefore, when it escapes, it will reach to velocity 0 and potential field 0. And from here you solve it and you need to reach a velocity about 11,000 meters per second squared. At this, if you reach this velocity, you leave the gravitational field. Problem number 4 is the following. Assume that an electron revolves around the photon in a circular orbit of radius. I have angstrom, which is a typical distance. What is the velocity of the electron and what is the frequency of its motion? So we know what is the charge of electron. We found it in Wikipedia probably. And we can calculate the force. F equals kq over r squared. K is 9 10 to the power 9. And the units substitute and you get 9 10 to the power minus 8 newtons. And then when we want to find the centrifugal force, so the centrifugal force is mv squared over r. You compare it with this force, and you'll get for v the following formula. And what you'll get that the velocity is what is very important to see. Are we getting close to the speed of light? We are getting a very high velocity, 2 times 10 to the power 6 meters per second square per second. It is, but it is 1% of the speed of light. Speed of light is 3 10 to the power 8. So it is getting close, but still not purely relativistic effects. We know the behavior change. So you cannot assign it because of the velocity. But if you take a look what with the acceleration, you'll see the acceleration is extremely high. You see the force was about 9 10 to the power minus 8, and the mass of the electron is 9 10 to the power minus 31. And you will divide this by 9 will cancel, and you'll get the acceleration will be 10 to the power 31 minus 8, 23. 10 to the power 23 meters per second square. You can imagine such acceleration. 10 to the power 22 times the acceleration that we can understand. So really the quantum region is a region extremely high acceleration. So if our model wants to reach there, we have to know how high acceleration affects our dynamics. And the omega, how many revolutions it has? 4.5 10 to the power 16 revolutions per second. It means everything moves very, very fast. Imagine that if you can measure something, a reasonable thing in nanoseconds, you'll have 10 to the power 7 revolutions. Even we do picoseconds, it's 10 to the power 12, we still have 10,000 revolutions. Therefore, it's understandable why we describe them probabilistically, because everything changes so fast. So we have to understand when things change so fast, what kind of new effects we are getting there. So with this, I'll send you, together with the presentation of the new lecture, this PowerPoint presentation.